through our network of air data routers like we have up here. Each air data router has 4 individual solenoid valves. Each valve is tied to an individual test area. So that individual test area could be a duct probe like this, which would be going into a supply reference air duct. So what this is going to do is a solenoid valve. It's going to draw that air sample back from the end device through our structured cable. So this is a electrically conductive nanotube, and this is something that will not break down over time. You know, this is basically made for the life of the building. So we're going to draw our air sample back through our network of air data routers. It's going to bring it back here to our sensor suite. Here that air sample is going to get analyzed for what happens to be on that particular project. So here we have a CO2 sensor, a dew point sensor, and a total volatile organic compound sensor. We can also do small particles, we can do carbon monoxide. So we're using the air supplying that space as a reference to that space. That allows us to compensate for sensor drift. So if a sensor drifts 20%, that differential in those 2 readings is going to be accurate. Whereas if you had a sensor in the room and a sensor in a piece of ductwork and they drift in different directions, well then you don't know, are you putting in way too much air into that room when it's not needed, wasting money, or are you not ventilating that room enough, creating a hazard for the occupants. So all of that information comes through here, and that's going to go back through our information management server. This is running the software that's controlling the Aircuity system. And these get hooked in to the building's management network. So we're sending out our data via a BACnet IP protocol, and they can act on that data. We'll send out a demand controlled ventilation function. So by comparing our readings, we're telling them how to ventilate that room. So the more that a particular parameter is going to drift, we're going to give them a rate of air changes per hour for that space, or cubic feet per minute for that space, where they should be putting the air. For every one of these sensor suites, like this one here, that's on a job site, every 6 months, Aircuity will send Flowtech replacement sensors for that sensor suite. So our service techs go out every 6 months and maintenance these systems. So what they would be doing, they would be going to the job site, and they may have 1 sensor suite like we have here, or we have jobs that have upwards of 10 or more, actually, in some cases. So they would be pulling the old sensors out, and they would be replacing the sensors with newly calibrated sensors that come from Aircuity's calibration lab. So these get put in line, they get attached to the sensor rail. So this is a carbon dioxide sensor. And then this other one, this is a dew point sensor. All sensors drift over time. So the reason why we do this every 6 months is to ensure the accuracy of the system and to make sure that over the life of the building that the system is still performing as accurate as it was the day that it was completed and started up. This is basically maintenance. It's maintenance, it's maintained. What this allows you to do, because this is what we call centralized monitoring, and by that we mean we have a centralized sensor suite. So these sensors now allow us to distribute a laboratory, very high-grade sensor across a larger footprint. So one of these sensor suites, in essence, could cover between 30 and 45,000 square feet of space.